Hello. Hello to Mr. Phillip, the CEO of Motivate and Motivate's management team. The Biker Gang would like to welcome you to our final report out of the Citi bike share demand analysis. Representing the Biker Gang team tonight is myself, John Jamara, and Megan Baldwin. Say hi, Megan.
Hi, John. It's good to be here with you this evening.
Likewise. So we're here to answer the question that you probably have, which is, what have we been doing all this time while you're paying us? We've been working hard over 10 weeks, and we know that we can answer that question for you. First, let's introduce the rest of the team. So you know, Megan and I are here, and Daraj, Dimitri, and Tyler are probably on a desert island somewhere, resting their brains after this intense effort that we put forth for Citi Bike. So here is the presentation outline, and we're going to take you through the problem and objective, which is why you hired us in the first place. We're going to take you through the data. Megan will discuss the modeling, and there's a dashboard that we created which we think is going to present data to you in a way that you may have never seen before. And then we're going to come up with some conclusions and an action plan for Motivate to take. So the problem and objective. So first, I want to ask you a question. What do these three pictures have in common? Besides the obvious, there are three examples of Citi Bike losing revenue. And this is why you came to us. We know that under contract with New York City, you're required to rebalance your bikes. You don't want to have empty bike stations around the city. It's bad for the city, it's bad for Citi Bike, and it's really bad for the program. But it doesn't mean that it has to cost you as much as it does. So you came to us and you said, hey, we want to create a model. We want a solution to this. We want to create a model to predict bike demand to help minimize the number of staff and trucks needed for rebalancing. And that's what we did. So let's get into it. Exploring the data. Exploring the data is like walking through the shops in Chinatown, as you see here. And you're never sure what you're going to find, but you'll know it when you see it. So the data is 33 million records. 33 million records. What does that mean? That's 33 million bike trips between July 2013 and September 2016. It had 15 variables or columns related to the rides, and we're using that to predict one variable, the number of rides. We enriched it with weather data, other demographics, and the quality was actually pretty good. Normally, we spend a lot more time cleaning up the data. This time, less than 1% were missing or erroneous. Very few outliers. And we did some transformations. It's typical in an engagement like this to perform some variable transformations. So, for example, we took the log of total trips, reduces it in scale, makes it a little less influential. You don't want it to be overly influential. We also did things like create a holiday flag. So, hey, this bike trip happened on a day that was a holiday, or this bike trip happened on a day that was a weekday. And we also did what any analyst worth their salt would do, which is to split the data into training and test. So 75% of the rows randomly selected would be used to train or develop the model, and then 25% is a holdout set, which we use to test the model, kind of like the scientific method. It's a control set, if you will. And I want you to be sure, this is big data. 33 million rows is a lot of information to work with. And what does big data mean? You've heard it a lot. It's a buzzword. It's out there. And it means that you can't use the normal tools, the run-of-the-mill tools, the run-of-the-mill technology to analyze it. Just to give you an example, Excel has a capacity of about 1 million rows. And if you have 1 million rows in Excel, it's even very hard to work with. So you do need the expertise, the specialized tools to be able to handle an assignment like this, which is what we used. And here are some of the tools that we used. We used our industry standard, very ubiquitous these days, completely free, but very powerful. Amazon Web Services and Google BigQuery, two cloud-based platforms, internet-based, virtual servers. So instead of being limited by the physical size of a server you might have, the space and the computing power is unlimited, essentially. Some very powerful engines there. Tableau, it's near ubiquitous. It's a very powerful tool. We use that to create the dashboard. And of course, Excel we used a little bit as well. So here are a few things we pulled out of it. 88% of all rides were taken by annual subscribers and only 12% by non-subscribers. So those are your casual riders, your tourists. So most of your business comes from people who know the program and they use it frequently, or at least they're subscribers. And gender, a little more than 3-to-1 males to females. And anecdotally, one of our analysts asked some of the females in his office if they use Citi Bike, and a lot of them said no because, especially for work, it's what they wear is not conducive to riding a bike, which makes sense. And here is the bike rebalancing. So each of the columns on top represents the number of bikes rebalanced over the time period of the analysis. The lines below, on average, represent an equivalent of 6.7% of all rides each month are rebalanced. So on average, 6.7% of all rides result in rebalancing. So out of 100 rides, 6.7% of those get rebalanced. So that's interesting. What else we noticed was that the greatest rates of rebalancing happen in winter. So you have a time where you have the lowest amount of revenue, but you're spending the most on bike rebalancing. There's an opportunity there. In our initial findings, we did find some important variables, and there are 3 categories. The first is geography. So the station ID and zip code, those essentially are the locations. So the locations of the stations are influential to the demand. Some neighborhoods are more active than others. The next is weather, precipitation, temperature, wind speed. You can think practically. If it's raining, the temperature's cold, there's a lot of wind, less people are riding bikes, and the other way around. And time of year, month. People may be riding more bikes, are more likely to ride a bike in the summer than in the winter. So now I'm going to hand it over to Megan to talk a little more about our predictive modeling.
Thanks, John. And I'm going to talk a little bit more about the nuts and bolts, kind of how we grease the chains with the models, so to speak. And we have a well-cited, peer-reviewed saying with us analysts that anyone who confuses correlation with causation eventually ends up dead. And so we're still here. We think we've found some good information, and we're going to share that with you right now. Next slide. And our analysis approach, in the initial data set, there was very few meaningful variables. So we wanted to enrich and transform that data set. What we found very meaningful in the beginning was the start station ID, where the station was located, and also the total ratio. So the total rides initiating from that station versus all of the rides that Citi Bike handles. This is a basic metric of how busy that station is. So we knew it was very important where the station was, probably its proximity to local sites, etc. And there's very stark differences between high volume stations and low volume stations. So we looked at some tree models that confirmed that the total ratio, whether a station is high volume or low volume, coupled with the month, has the most predictive accuracy in looking at predicting how many rides are emanating or leaving a specific station. So once we had that information in hand, we're going to look at some different methods and models that we use to delve deeper into the data set. Next slide. So initially we took the data from the origin of what Citi Bike is publishing on the Google Cloud to when they stopped publishing on the Google Cloud. With that data set, we ran the decision tree, we ran random forest, we ran gradient boosting at that stage. Again, to reiterate what John said, these are 33 million records. It's quite a lot of information for these models to crunch through, so we had a limited amount of tools with this entire data set. Once we got some initial information with that, we were able to work and apply that to more current data. And we can see here that some of the models were, because of the computational power needed to run them with gradient boosting and neural networks, we selected a smaller set of data. It was basically just looking at historic trips happening in September to predict September's rides. And there is, we can see here, a big differentiation in time to run the models and additional cost to run the models. So moving forward, that is why we're looking to work with gradient boosting and neural networks, because of the scalability and the ability to maintain somewhat close predictive ability measured by the mean square error with smaller information sets. And next slide. So the best model that we have worked with has been the gradient boosting. During the model development, where we worked with the full data set, it had very good predictive power that we were able to get a mean square error on that of about 300, which put us within about 15 to 20 bikes per station in our predictive ability up or down. Moving forward with a smaller data set, trying to predict September data from past September trips, it was not the best performing. However, we were able to use a smaller data set for model calibration. It provides us some agility with moving forward and doing further work. The model parameters for the gradient boosting were retained from the larger data set, and however may need to be adjusted on the smaller data set to get that better predictive ability. So these give us opportunities for improvement working with these models. And next slide. So model issues and future improvement. We started out with a limited number of variables. We now have a model that we believe is agile enough to work on adding and taking away variables that we believe will enhance predictive power. And one thing we found in the data set is that from 2014 to 2015, Citi Bike has consistently added about 33,000 subscribers per year. there was a significant jump to 46,000 subscribers in 2016. We have not found the right variables to look further into that spike in rider growth. With the model power that we have and the agility, we can look further into understanding where we are in an exponential growth curve and what we think will happen, or how that growth will either continue in an exponential trajectory or somehow taper off. And we want to make sure with our variable selection that we are avoiding overfitting. Some of the issues with applying the models from 2014, 2015 to 2016 and beyond to 2017 could be caused by tuning too close into historic trends. So some of these more agile models and smaller data sets allow the ability to focus on some more simple forms and to be able to update and use rolling data sets. So we can drop off early years, we can take out 2013 data, and looking towards 2017, we can take out 2014 data to focus on some of these later trends. And at this point, I'm going to hand it back to John, and he will cover our dashboard and conclusion. Thanks, John.
Thank you, Megan. And so now, as Megan mentioned, I'd like to show you the dashboard. So Megan took you through the deep analytics, where our expertise lies, and we've proven that we can create a predictive model out of this data to help motivate. But to operationalize some of that and some other data that you have, we're going to take a look at this dashboard, which I already have up. Here. So the dashboard has 2 pages, if you will. The first page shows a map of the city, New York City, and each of these purple dots represents the total bikes available at given stations. The darker the dot, the more bikes there are available. So at a glance, you can see the whole city and what the total bikes situation looks like. So we also have total docks available. So we have how many bikes are there and how many empty docks are. So you can show it to people, or you can use it to make sure that you have not only ample bikes for those looking to ride, but ample spaces for those looking to end a ride, right? So this is based on the real-time data feed that we found in the JSON, the JSON format. And we can use these sliders on your dashboard to set limits on the number of bikes that we're looking for. So if we're looking for, let's see, anything with 0 docks available, we can use the slider. That will update. You can move this slider down here. Okay, so now that we lowered the threshold on available bikes, you can see that a lot more stations showed up. So as we move this slider up and down, we can see the dots disappear. So depending on what you're looking for, you can adjust this here. So this stock ticker type presentation down here on the right gives just the overall picture. So you're not necessarily going to be using this particular graph to pinpoint a station, but as a stock ticker does, it gives you a trend. So down below, we see the purple represents the bikes, and bikes available, and the orange represents the docks available. So these are sorted in highest to lowest. So you can see here, for example, the station that is at West 33rd Street and 7th Avenue has 59 bikes available. But clearly not the same. Clearly the station with the most docks available is very different. So this is a foundation, and it is very flexible, and we can do lots of different things here, but this is our first presentation to you, so we'll be looking for your feedback on how you might want to modify that. So that's page 1 of the dashboard. Page 2 of the dashboard, this is where we put in 1 month of data, and on the left we have incoming trips in the brown. On the right we have outgoing trips in the yellow. It's just refreshed there. And again, this is a foundation. It is used, it can be used for seeing trends in where the bikes are flowing throughout the city. So potentially we could add neighborhoods to this, add a few more months. And so, for example, we know that the program has an issue where a lot of people are taking bikes from Manhattan out to the outer boroughs, but they're not taking the bikes back in. So that's an opportunity to maybe figure out some other way to prevent that from happening. And you can see these trends here. Perhaps in real time, you can combine those two functionalities, and that'll be something else of value that you can take. So this is looking at all stations. So if we just wanted to select a handful of them, we can click here, and then I'll select these. We'll see what that gives us. So here's just a cross-section of some stations. So again, the stations listed in in descending order with the largest number of incoming trips and the largest number of outgoing trips. They're not the same stations, right? So again, that speaks to the issue at hand of bike rebalancing. And this is just one way of presenting it. There's many more options that we can explore for you to implement in this flexible dashboard. So returning back to the presentation. So that's our live dashboard. So now we'll talk about our conclusions. What should motivate, take away from this, and some additional learnings, some value add that we created along the way. So we'll start with the additional learnings. So we use the Google Cloud Platform, as I mentioned. That's where the 33 million records were housed. And some pros that it's very fast. It is designed for large data sets, and there's plenty of documentation. One of the cons are that it's not very intuitive, and to get started, we got bounced around to many different websites, and the documentation is a little circular. So ultimately, we would not recommend using this again. On the contrary, Amazon Web Services, very user-friendly, unified interface, also fast, also designed for large data sets. There is no free option, but and support was a little hard to come by without paying at the premium level, but leaps and bounds above the Google platform, and we consider that best in class. We would recommend this absolutely for future endeavors, and we plan to shift all of our work over to Amazon as well. And the third column here is the Shiny from RStudio. This is the software that we embarked on to create a cell phone app, which we did not complete. Ultimately, we decided to adjust our resources and apply them to the dashboard for this reason. The large size of the data set made working with the Shiny app a little too cumbersome for usability. And while that's something that we could work out, eventually it was going to take a lot more time. So we spent some time and developed some things, but when we realized we hit this snag, we shifted everything over to the Tableau dashboard, which we think paid dividends. So our recommendation on this is inconclusive. We would definitely pursue doing it again, but we can't make a full recommendation to you without having a completed product in this regard. So ultimately, what's the action plan for Motivate? Well, we provided a dashboard, and we think that you should use that to help schedule the amount of bikes, rebalancing staff, and the amount of trucks to rebalance bikes around the city. And for the following 12 months, we will update the predictions into that dashboard weekly, where weather is a big part of the model, and we know weather changes each month. So we'll have a prediction that we will put out there and update it without any interaction from you. It'll just be there. So we recommend you use it for bike rebalancing. We also recommend that you monitor for trends in the number of bikes rebalanced as a percent of total rides, as demonstrated earlier. And we think that's an important factor to measure, because then you can start looking at number 3, which is the cost of bikes rebalanced. And we noticed that the cost you have now is just for overall. And we recommend that you break this down by each transportation method using an equation like this one. Because as you're trying new transportation methods, you certainly want to know which one is working better than others from a cost perspective. And finally, we recommend that you re-engage with us in 6 months to determine if the model needs to be tuned up a bit. Information changes over time, situations change over time, and certainly it's reasonable to think that the model will have to be modified, revised, and that's certainly a best practice that we offer to you. So overall, we're very, very proud of this effort, and we're confident this will help you improve how you will do business. Thank you so much for your time.